Welcome to this episode of more simply linked lists. So I'll be splitting this task into several depending on the task. So I'm going to separate the task, right? It's not going to be like that long one. Probably at the end I might then merge it together and then make it one because I'm busy and I will just be doing them and then going back to what I'm doing. Alright, so I'll be doing them singly because I don't have a lot of time to. I have some deadlines to meet up with. So this is just a part two of singly linked list, right? So there will be no quiz here since this one is like a continuation, right? So you can just go through. I think all these requirements are basic requirements like. They are just they are requirements that are there permanently. So sometimes it's like, for example, this picture you might not use it at the end of the day. You understand? So all these requirements are just basic. So there are sometimes I think here any use of functions like printf, all this is forbidden, but in the project you can actually use it. In some projects it will be there that you can use if you're allowed to use printf. So just try and read the instructions and then get to them. Alright, so let me see deep into my ALX low level. And okay, because I haven't created the stuff yet. So for this one we did part one of singly linked list. Let me see if I still have that picture here where I was using to explain, so I can use it to explain. This one is more simpler, is more simpler version because it's, I think, much I haven't gone through all the tags, but I think the first two or three tags are just single data. They have single data just like this one, unlike the previous one when we have each node was containing two data, which is the string and a string length. But this one is now talking about the an integer, right? Like yeah, I think int, right? So I think it's integer or a float, but I think basically it's integer. All right, so what we're gonna do now is we're gonna just come here. So we have to write a function that will print all the elements of a list. So this is the name of the list, right? So it's going to print all the elements of it, right? And as you can see, when they were testing it, we will have a string.h, right? I think that would be about header file. Is that okay? Sorry, list.h. So string.h is the string. Is a string header file that comes with your laptop, right? So this one is the list.h is going to be it's going to be a header file. We have the standard IO, standard input, and we have the string for strings, and then we have standard library for malloc, right? So basically they use this to test your code, and then at the end when they pass in your function that you've written. What's the name of the function? Print list. Let's see. So when they pass the head of that list, this is the list, sorry, this is the list, this is the head. When they pass in this head to it, it's going to automatically print out all the data like 10, 20, 30, and 10 inside that singly linked list, because with the head we can access all the content of the list, right? So when they pass in this to this guy and they execute it, it's showing that they have 9, 8, right? And then two elements, right? So it's showing that they have one element called 9 and then one element called 8. Where's the 8? They declared it somewhere. Let me see. Is it somewhere? I'm trying to see where the 8 is being declared. Anyway, regardless of that, probably is this a minor sign or what? Anyway, let's just continue. So basically, what we're gonna do is we're going to create our directory, right? Then we seed into that directory. Oh shit! I wanted to create directory. I was VIing directory. Sorry. Remove, make directory. Alright, so we'll cd into the directory, and then there's nothing there. Let me clear it. So vi, we'll create our readme. What did I just do? Okay, I think I did the right thing. Right, good. Yes, we're correct. So clear ls. So we have our readme already, so you can add more details about your readme. Right, your readme should contain. I've seen so many people writing readmes very long. I don't really like reading things that are too long. Just make it short and discreet, like make it explanatory, just like a sentence, so they just know what it's all about. Like nobody has a luxury of time to start reading. They've not even read your code and they have to spend so many times still reading your readme. So I don't know. Do what works for you. Alright, so the next thing is we'll create this file, right? But before that, we'll create our header file, right, which will contain our prototype and our struct. Okay, according to ALX, when you are creating your struct, you should always put it in your header file. Alright, so we'll be putting our struct in our header file. Okay, so it's one of the requirements for ALX. So list, I think list.h, because last time I think I wrote list, ordinary list somewhere, I can't remember. So it should be list.h. So we will say if not defined, right, list, right, and then we'll say, sorry, let me add my s to it to make it complete. It's not compulsory, just make sure that whatever you put at the top is what you're putting at the bottom, right? So define list, right, and then we'll end it, right? Good. So the next thing we're going to do is we're going to get the prototype as well. So the prototype will be at the bottom, because we had that issue the last time where the prototype was up above the struct and it was giving issue. Alright, so put the prototype down, and then we would then define our struct. Okay, so our struct will be if you look at it, our struct has been type def to this guy, right? List integer underscore t. Okay, so it has been type def to them. So I can just say type def, but what we want to create is a struct, right? So our struct, I can call it list s, right? And then create this. I'll put a space and then paste this guy and then end it like this. So this is our new name for struct list. S is now struct int t, right? Struct int s is now struct int t. So what will be inside? We'll have our data and then we'll have our link. It's a self-referential structure that creates a node. So we are just trying to create a structure of nodes, right? Okay, so we'll just say we have our integer n, because I think so far it's just going to be a single data type, not like the other one that is a string. I think that one should have come later. This one should have come first, because this one is, I think, more simpler. I don't know. So we have our struct list s, right, and then a pointer to the next guy. And then don't forget, we have to also document our struct using Betty standard, right? So we'll say struct, right? Struct this is what is a singly length, or is a self-referential referential, am I correct? I don't know. Structure for creating nodes of a singly linked list, right? So the next thing we have is our parameter. We have n and we have next, right? So we have at n, which will be the integer data type, integer data, and then we have our next, right, which is the self-referential pointer or pointer to the next node of a list, right? So we end it like that, and I think we are good with that. So what we then do is we then create our file and do our code. But before that, as you all know, we create our git ignore, and then what are we going to put? All our anything that end with main.c, and also maybe, I don't know, but I'm sure that we would have abcd like that. All those are executable. I'm doing this because I don't know which one they are going to use anyway. So anyone they use, I'm sure our git ignore would ignore any of those files. So let me clear it, and then so far, if I do early, we'll have our git ignore as well. So what else? Okay, so our main.c, so our vi0 main.c itself. So hey, I didn't do it wrong. I didn't add my dot, it wasn't there. vi0 main.c. Okay, and then back to that, who is in support of what is going on in Mali? To me, I feel it's necessary because these African heads are just raping the citizens. They're just looting their country's fund. Anyway, that's by the way. So I'll paste this here, and then I'll save this. So we are almost done. At least if we don't even know anything and you can get to this point, it's something. It's just your coding that you just need to work on, right? So we'll then copy this guy again, or yes, let's copy it. Though we need to use this prototype to define our function. But what's the function name? The function is 0 print list int. That's it. Let me just copy this guy because I can't be cracking my head and storing all this data. So I'll vi this, right, and then I'll go back up, and then just copy this guy, right? So let me remove insert next back enter this. Okay, let's first do our stuff. We include, so let me save this. The thing is, we are going to use let me go back to my list. So let me just add some things, right? So we are going to use some header file that comes with our compiler, our machine rather, the global header file. So we are going to include, let me include it here. I don't want to be including it in all the files manually, like one by one. So stdio.h, because we'll be using printf I think almost all the time, and then we're going to include standard library, right? So I think these two should do. This one for printf, this one for malloc, right? Standard library.h. I think that should be all for now. So what we're going to do next is we're going to I'm busy. Okay, so sorry about that. Vi back into our 0 print. Let's see, and then we'll just include main.c. Sorry, this guy has confused me. Our list.h, right? So then we'll document this guy. I will say this one should be print underscore list integer, right? So we'll say you should print list integer, and then we'll say this one is to print the integer data in a list, in a singly linked list. You're going to print data though, it doesn't have to be, the function will print data, it doesn't have to be integer, but I'm just being specific. Alright, so the next thing we're going to do is we're going to create h, right? So put space at h. So this one is the head pointer to the list, right? Okay, so and then we'll have a return, right? Sorry. So our return is going to return the number of nodes, right, in the list. I hope so. I have to confirm that. So let me confirm. Are you returning the number of nodes? Okay. So it's going to print the elements there, and also it's going to return the number of nodes, and then says C format, and then you're allowed to use printf. So the format will allow you arrange what you are supposed to do, right? So I think we have 9, 8, and then it's going to say the number of elements. Alright, percentage elements. Okay. We return this. Alright. So what we then do is, let me come here, and then so this is where the small work is. Alright. So what I'm going to do is because we are going to return the number, so it's going to be counting. So I will have a count. So let me have an unsigned integer as count, right? So because we have standard library, I think we will be able to use this size underscore c. It means unsigned integer, right? So positive, so from 0 upward. Alright, so we'll then say that if our header, right, is equal to null, you should return 0. Right? So that's what we're saying. We're saying that if this guy is pointing to nothing, that is, this list does not exist, then you should just return 0. But what if it's pointing to something like this node A? Okay, so what if it is that has been connected to a list? Okay, so if it is, then we can use a for loop or a while loop, anyone. So we'll say for, and then we'll say count is equal to 0. Okay, so our count is 0, So we want to use this one to count. As far as age is not equal, age is not, sorry, as far as age is not equal to null, right? So we are saying that as far as this age, this is the header, as far as it has not gotten to this end, right, then it should continue counting, right? Count plus plus. What will be in our code? Then we then say, so once it goes to the first one, it's going to print out the data, right? So when this guy goes to the first guy, because it's not equal to null, you want to access this data, right? Okay, so to access that data, there's a pointer in our struct that is pointing to the struct itself. So we use that one to access, dereference it, and then use it to access our data, which is n, right? So we'll just say that print the data, print n, and then 2 colon, and then we'll say %d, %d, and then a new line, comma, and then what are we printing? We are printing head, we are dereferencing head, so I will use this dash this arrow, right, and then n. So I'm saying that I'm dereferencing h, this pointer, this is the header, right? This head, let me see if there is a better picture. Yes. Oh wow, let me see this one. Yes, this is the head, right? So I'm using this head, dereferencing it to point to n. So I'm saying head arrow n of this one, right? If I say arrow next, I'm talking to this guy. Arrow n, I'm talking to the data, because our data is n in the struct we created, right? So that's what I'm doing. So I then come here and then say you should print that, and then if it comes back again and it has gone to the next guy, right? So this count has increased, but our head will still be at the same position. So we need to increment head to be pointing at something else, to be pointing at this guy the next time we want to print it. Okay, so what we then do is we then say our head will then equal to, after the first time, head next. Okay, that is, we are saying that our head is now instead of this guy, right? We are then saying that it is now pointing to this next guy, right? So now that it is pointing to this guy, it's pointing to this address, right? Then we can then access the data by dereferencing it. So when it comes back here, it will reaccess it. So let's just still try this and then see. So we'll return, because we are returning an unsigned integer, as you can see, size underscore t, right? So we have count. So because we are returning an unsigned integer, right? So that's why we need to return unsigned integer here, right? So that should work. So we'll then do like this, and yes. So if we want to compile, let's try and see. A, so it is A here. So I'll copy and paste. We don't have any error. Let's bet it that file first. 0 print, and let's bet our list.h. zero print has just one error. List.h has one error as well. Okay, so vi zero print has trailing white space at number 4, right? So vi zero print 1 2 3 4. Oh yeah, in the description, I guess. Okay, just this place. So I've removed that one, and we have list.h as destruct list destruct. They say no. Okay, sorry, it's supposed to be s. All right, so let me clear it and we betty it too. So we have this, and then we have this corrected. So let me recompile, right? And then we are good. So let me run it, and then we have now 8 and then 2 elements. I think we are good like this, right? So I think these 2 elements, right, it is from their side. They've already, it's inside their main.h, right? So they've already counted it, and then it's going to print it for you, right? So you're not the one to do this one, right? What else? This 8, I'm trying to see where they figure it out. If I go through it very well, I'm going to figure it out, but because of time, you can just try and figure it out. If you figure it out, you can put it on the comment section so that someone can learn from it. Okay, so thank you. All right, so what else? I think this is done. So for the second part, oh sorry, we need to check our code. So after this one, we'll see you in this one, right? So I'll be making a separate video for this one. So let's test our code and see if it works. Okay, we have some fail. Oh sorry, I haven't pushed it. It's going to fail everything. All right, so git add. Since we ignored all the files we don't need to, we can git add everything, and then I can git commit and say this one. What is this program doing? It is printing the list of a singly link, printing the data. Printing the data of a singly linked list and returning the number of data, right? And then we git push. So I'll be making the videos one by one like that, and I'll be uploading it, and then probably at the end I'm going to have a merged video for everything, for people that just want to see it as a go. All right, so we are good. So we'll go to the next one, and then I'll see you on that. So bye.